Welcome back to our unit over nomenclature. In this video, we are investigating how to name and write the formulas for molecular, aka covalent compounds. Have your periodic tables handy and take meaningful notes. Why do covalent bonds form? Covalent bonding occurs between nonmetals or metalloids to create a molecular or covalent compound. By sharing valence electrons, the shared electrons effectively fill the outermost energy level of each bonded atom to achieve an octet of electrons, and therefore they become more stable. Electron attraction to a nearby nucleus creates covalent bonding. How do we write formulas for binary molecular compounds? Remember, binary means two, so there are two elements involved in those compounds. We are going to look at two examples as we go through the rules. Our first example is nitrogen pentasulfide. Rule number 1. Write the symbol for the first element. The first element is nitrogen, so I write N for nitrogen. Number 2, add the subscript that corresponds to the number of atoms of the first element present in the compound. If there is no prefix, we assume 1. So there is no prefix in front of nitrogen, so I have 1 nitrogen and I just leave the N alone. Number 4, write the symbol for the second element. My second element says pentasulfide. Sulfide comes from the element sulfur, so I write S. Number 5 says add the subscript that corresponds to the number of atoms of the second element. We have already learned those prefixes when we did hydrates. You have to review them and make sure that you know them. So pentasulfide means I have 5 sulfurs, so S5. And finally, we do not reduce the formula. There is no need to reduce this formula anyway, so it wouldn't apply there. Our second example is disulfur tetroxide. Write the symbol for the first element, sulfur. So I'll write S. Add the subscript that corresponds to the number of atoms of the first element. I have disulfur, which means I have 2 sulfurs, so I write the subscript 2. Write the symbol for the second element. I have tetroxide. Oxide is for the element oxygen. And then I add the subscript that corresponds to the number of atoms of the second element, and that is tetra, which is 4. So S2O4. Finally, it says do not reduce the formula. We do not reduce formulas of molecular or covalent compounds. So S2O4 stays just like that, and we don't reduce it. Let's practice a few more examples. Number 1, nitrogen tetroxide. So I have an N for nitrogen. I do not have a prefix in front of nitrogen, so I assume a 1 and I leave it alone. Tetroxide, tetra is for 4, so I have 4 oxygens, so O4. Carbon monoxide, I have 1 carbon and I leave it alone. Then I have monoxide, mono is for 1. So 1 oxygen, so CO. Triphosphorus pentachloride, phosphorus is P. I have triphosphorus, so I have 3 phosphorus. Pentachloride, chloride comes from the element chlorine. Penta is 5, so I have 5 chlorines. Dioxygen hexafluoride, I have oxygen, di is for 2, so 2 oxygen. Hexafluoride, fluoride is from the element fluorine, and hexa is 6, so 6. Again, I do not reduce this. Now let's take a look at how we go from the formula to the name. In our first example, we have NO. Name the first element. The first element is nitrogen. Then it says include a prefix if two or more atoms of that element are present, never use the prefix mono for the first element. So we do have only one nitrogen, but I do not use mono on the first element. Number 3 says name the second element and change the ending to "ide." So my second element is oxygen, so it becomes oxide. And I have to include a prefix in all cases for the second element, even for mono. So I only have one oxygen, but this time I do have to use the mono. So nitrogen monoxide. Our second example is O2Cl7. So we name the first element, it is oxygen, and we include a prefix if two or more atoms of that element are present. We have O2, so 2 is di, so I have to say dioxygen. Then I name the second element and change the ending to "ide." My second element is Cl, so chlorine, which becomes chloride, and I include the prefix. We have 7 chlorides, so 7 is hepta, so hepta and chloride. Let's practice a few more. S2O. S is sulfur, and I have 2 sulfurs, so disulfur. My second element is oxygen, and I have 1. So we do have to use the term mono for the second one, so disulfur monoxide. Number 2, we have OF2. We have 1 oxygen, so we do not use mono on the first one, so just oxygen. And then we have F2. F is fluorine, so it becomes fluoride, and since we have 2 of them, we have difluoride. Finally, we have Si2Br5. Si is silicon, and we have 2 silicons, so it is disilicon. We have 5 bromines. Bromine changes to bromide. 5 is penta, so pentabromide. There are a few molecular or covalent compounds with common names, and we have to use their common names instead of their molecular names. These are methane, CH4, not carbon tetrahydride. Then ammonia, we learned that when we were doing the bases. Ammonia is NH3, not nitrogen trihydride. And finally, water is H2O. You need to be familiar with those 3. This concludes our video for today. I hope you have taken good notes. Come to class prepared with your questions.